Hello, in this lecture we'll find out the maximum area of a rectangle that is inside a triangle. In the drawing we have triangle ABC. Side AB of triangle ABC equals to 10 units in its length, side AC equals to 17 units in its length, side BC equals to 21 units. Inside this triangle ABC we have this rectangle PQST. And our mission is to find out the maximum area of this rectangle PQST. So in the first step, we do a construction, that is to say from point A, we draw perpendicular on PQ. So this angle equals to 90 degrees. And this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and PQ. This point is point M. In the next step, we extend the perpendicular AM by a straight line until it touches side BC. And we define the touching point of the extended perpendicular AM and side BC. This point is point N. So actually, by doing this construction, here we created here two corresponding angles. Those two angles are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other. But this angle equals to 90 degrees, therefore this angle must be also equal to 90 degrees in its size. Likewise, those two angles are also corresponding angles, and they are located between the same parallel lines PQ and BC, and therefore they are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees. We use the rule that corresponding angles between parallel lines are equal to each other. In the next step, we define the length of this line segment BN as x. So what is the length of this line segment NC? We're going to very easy to see that NC equals to BC minus BN. Again, NC equals to BC minus BN. Write it down. NC equals to BC minus BN. So NC equals to BC, that is 21 units in its length according to what is given in the question, minus BN equals to x according to our definition. So in total, NC equals to 21 minus x. So here NC equals to 21 minus x units in its length. So in the next step, I'll copy this right triangle A and B in a new page, and we'll implement the Pythagoras theorem on this right triangle A and B. according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the relation for Pythagoras theorem. So side BN equals to x, and the hypotenuse AB equals to 10 units in its length according to what is given in the question. So actually, this is the right triangle ABN, the curvature of the original drawing. So according to the Pythagoras theorem, in this right triangle ABN, AB square equals to AN square plus BN square. So I write it down. AB square equals to AN square plus BN square. This is equation 1. The hypotenuse AB is 10, therefore AB square is 10 square, that is 100. And it is equals to AN square. AN is the missing side, so we leave it as it is. AN square plus BN square. BN is x, therefore BN square is x square. The conclusion found out that according to equation 1, 100 equals to AN square plus x square. Here we subtract x square from this equation 1. And finally we get that according to this equation 1, AN square equals to 100 minus x square. In the next step, I'll copy the right triangle A and C, this right triangle A and C in a new page, and we will implement the Pythagoras theorem on this right triangle A and C. Again, here by PT is the relation for Pythagoras theorem. The hypotenuse AC of the right triangle A and C equals to 17 units in its length according to what is given in the question. Inside NC equals to 21 minus x units. So actually, this is the right triangle A and C that the curvature of the original drawing. So according to the Pythagoras theorem, in this right triangle A and C, AC square equals to AN square plus NC square. So I write it down. This will be equation 2. So AC square, that is the square of the hypotenuse, equals to AN square plus NC square. AC is 17, therefore AC square is 17 squared, that is 289. And it is equals to AN square. AN is the missing side, so we leave it as it is. Plus NC square. NC is 21 minus x, therefore NC square is 21 minus x square. So here we subtract 21 minus x square from this equation, equation 2. And we get that according to equation 2, $289 minus 21 minus x square equals to AN square. This is according to equation 2. While according to equation 1, we have already found out that 100 minus x square equals to AN square. So we have two equations for the value of AN square. Therefore, we create equation 3. Let's say that AN square, according to equation 1, must be equal to AN square according to equation 2. Repeat again, we created equation 3. It says that AN square according to equation 1 must be equal to AN square according to equation 2. So AN square according to equation 1 is 100 minus x square, and it must be equal to AN square according to equation 2. AN square according to equation 2 is 289 minus 21 minus x square. In the next step, we will open the brackets of this expression 21 minus x squared, and we get that according to equation 3, 100 minus x squared equals to 289 minus here 21 minus x squared equals to 21 squared, that is 441 plus x squared minus 2 times 21 times x is minus 42x. So according to equation 3, 100 minus x squared equals to 289, and here we have minus before the brackets, so we'll open the brackets of this expression, and we get that here we have to open the brackets. This expression will be equal to minus 441, and here we have minus x squared, and here we have minus times minus is plus, so minus 42x is plus 42x. So here we add 441 to this equation 3, and get that according to this equation 3, 100 plus 441 is 541 minus x squared equals to 289 minus x squared plus 42x. So here we have x squared on both sides, minus x squared on both sides of this equation 3, so x squared will get cancelled, and after we cancel x squared, in this side of equation 3 we left only be 541, and the other side of the equation we have left with 289 plus 42x. So here, so according to equation 3, we found out that 541 equals to 289 plus 42x. So here we subtract 289 from this equation 3, and finally we get that according to equation 3, (541 minus 289 is 255, so 252, so 252 equals to 40 times x. Here we divide this equation 3 by 42. 252 equals to 42x. We divide this equation 3 by 42, and we get that x equals to 252 over 42 is 6, so x equals to 6 units in its length. That is to say, the length of distance 7pn that is equal to x according to our definition is equal to 6 units. And here we have line segment NC that is equal to 21 minus x, and x is 6, so it is 21 minus 6, that is 15. In the next step, we return to equation 1. According to equation 1, we found out that an squared equals to 100 minus x squared. But we just right now found out that x equals to 6, therefore x squared is 6 squared, that is 36. So according to equation 1, an squared equals to 100 and minus 36, and 100 minus x squared, and x squared is 36, so it is 100 minus 36, that is 64. So according to equation 1, an squared equals to 64. Here we take out all of this equation, and finally get that an equals to the square root of 64, that is 8. So actually, this is line segment AN or side AN, and it is equal to 8 units in its length. So I write it down. AN equals to 8 units in its length. It is given as the question that PQST is a rectangle, and we know that all the angles inside the rectangle are right angles. That is to say, this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size. In the next step, we will focus, but before that, we will define the width of rectangle PQST as B. That is to say, QS equals to B, and we define the length PQ of rectangle PQST as B as A. PQ equals to A according to our definition. And the width QS equals to B also according to our definition. Okay. In the next step we will focus on this small quadrangle MQST. Inside this small quadrangle MQST, we have 1, 2, 3 right angles. The sum of right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So this angle equals to 90 degrees. So inside the small quadrangle MQST and MQSN, this is quadrangle MQSN, we have 4 right angles, and according to rule 6, any quadrangle that has 4 right angles must be this rectangle, if not a square. So we relate to this small quadrangle MQSN as a rectangle, because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in the small rectangle MQSN, side QS must be equal to the opposite side MN. But QS is B, therefore MN must be also equal to B. So I write it down. MN equals to B. What is the length of line segment AM? From the drawing, it is very easy to see that AM equals to AN minus MN. Again, AM equals to AN minus MN. So I write it down. AM equals to AN minus MN. So AM equals to AN, that is 8. Minus MN, we just right now found out that MN equals to B. So in total, AM equals to 8 minus B. AM equals to 8 minus B. So we know that those two angles they are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other. So if we define this angle as alpha, then this angle must be also equal to alpha because they are equal to each other. So write it down. Likewise, those two angles they're also defined as corresponding angles, and they are located between the same parallel lines PQ and BC, and therefore they are equal to each other. So we define the side of this angle as beta, then this angle must be also equal to beta because they are equal to each other. In the next step, we'll prove that the big triangle ABC is similar to the small triangle APQ. Okay. So why the big triangle ABC is similar to this small right triangle? This small triangle is not the right triangle. Why the big triangle ABC is similar to the small triangle APQ? So first of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles they are both equal to beta, and therefore they are equal to each other. And finally, this is angle A. It is a common angle, it belongs to both triangles, so I can write down that angle A equals to itself. It's a common angle that belongs to both triangles. So we actually proved that all the triangles in the big triangle ABC are correspondingly equal to all the triangles in this small triangle APQ. And therefore, those triangles are similar to each other according to angle similarity rule. So write it down. The big triangle ABC is similar, this is the sign of similar, to the small triangle APQ. According to angle similarity rule. And we also know that if two triangles are similar to each other, then the ratio between their heights is equal to the ratio between their sides, or the ratio between the corresponding sides of the two similar triangles must be equal to the ratio between the two corresponding. Again, the ratio between the two corresponding heights must be equal to the ratio between the two corresponding sides. So that is to say, if we focus on the two similar triangles, triangle ABC and triangle APQ, it means that the height AM in the small triangle APQ, the ratio between the heights is the height AM in the small triangle APQ over the height AN in the big triangle ABC. So that is the ratio between the heights must be equal to the ratio between the corresponding sides. So it must be equal to the ratio between side PQ of the small triangle APQ over side BC of the big triangle, triangle ABC. The meaning of this equation 1 is that the ratio between the heights of the two similar triangles, that is actually AM over AN, must be equal to the ratio between the corresponding sides, that is to say PQ over BC. AM equals to 8 minus B over AN. AN equals to 8, and it is equals to PQ. PQ equals to A, according to our definition, over BC. BC equals to 21 units in its length, according to what is given in the question. So actually I found out that according to equation 1, 8 minus B over 8 equals to A over 21. So here we cross multiply this equation, equation 1, and we get that A equals to 21 times 8 minus B. So here we divide this equation, equation 1, by 8. So we get that according to this equation 1, A equals to 21 over 8 times 8 minus B. So here we will open the brackets on this side of this equation, equation 1, and we get that according to this equation 1, A equals to, here we have 21 times 8 over 8 is 21, and here we have 21 over 8 times minus B equals to minus 21 over 8 times B. So actually according to equation 1, we found out that A, that is the length of rectangle PQST, A equals to 21 minus 21 over 8B. So here we multiply this equation, equation 1 by B. So you get that here in this side of the equation we have A times B equals to 21 times B, and here we have minus 21 over 8 times B equals to minus 21 over 8 B squared. So according to equation 1, we found out that A times B equals to 21B minus 21 over 8 B squared. But what is actually A times B? A is the length of this rectangle PQST, and B is the width. And note that the length times the width is the area of rectangle PQST. That is to say, according to equation 1, we actually found out that the area of rectangle PQST equals to 21 times B minus 21 over 8 times B squared. It is actually, this function is the area of rectangle PQST as function of B, as function of the width B. And our mission is to find out the maximum area of this rectangle PQST. Or in other words, our mission is to find out the maximum value of this function area of rectangle PQST, or for which B this function will get its maximum value. What does it mean? It gets its maximum value. It means that the area A times B will be in its maximum value. In order to find out what is the maximum value for which B, the area or A times B will be at its maximum value, we will have to differentiate this function area of rectangle PQST, and then we will equate the derivative to 0. In this way, we get the extreme points of this function area, and in order to find out whether if the extreme point that we got it is maximum extreme point or minimum extreme point, I will just draw the function area, and from the graph we can easily see whether if the extreme point that we got it is a minimum extreme point or a maximum extreme point. So in the first step we will differentiate this function area, and we will equate the derivative to 0. So here D is the expression for derivative, so the derivative of the function area, that is actually 21b minus 21 over 8 b squared. And we will differentiate it according to the independent variable b. Okay, and we will equate this derivative to 0 in order to find out the extreme points of this function area. Okay, so what is the derivative of 21b? We know that the derivative of b is 1, and therefore in total the derivative of 21b will be equal to 21 times 1, that is 21. And what is the derivative of minus 21 over 8 times b squared? Actually, we know that the derivative of b squared is 2b. Therefore, this expression in total will be equal to minus 21 over 8 times 2b. And it is equal to 0. So, in this equation 2, we found that the derivative of the function area of rectangle PQST equals to 21 minus 21 over 8 times 2b, and the derivative equals to 0. In order we equate this derivative to 0 in order to find out extreme points of the function area. So here we take 21 as a common factor out of those two expressions. So 21 is taken out as a common factor. So what is left from 21 after we took away 21 as a common factor? What is left is actually 1. And what is left from this expression, minus 21 over 8 times 2b after we took from it 21 as a common factor? What is left is actually minus 2b over 8, and it is equal to 0. So here we divide this equation 2 by 21. So here we have 21 over 21 is 1, so we left only with 1 minus 2b over 8. And the other side of the equation we have 0 over 21 is 0. So according to equation 2, we found out that 1 minus 2b over 8 equals to 0. Here we add 2b over 8 to this equation 2, and finally we get that for this equation 2, 1 equals to 2b over 8. So here we will divide both the numerator and the denominator of this expression by 2, and we get that according to equation 2, 1 equals to 2b over 2 is b, and 8 over 2 is 4. So according to equation 1, we found out that 1 equals to b over 4. Here we multiply this equation 2 by 4, and finally we get that b, the width b, equals to 4 units. That is to say, actually found out when the width b is equals to 4 or 4 units, we have extreme points of the function area. In order to find out whether if b is equal to 4 it is minimum extreme point or maximum extreme point, we have to draw the function area, and from the graph we can easily see whether if the point b equals to 4 it is minimum extreme point or maximum extreme point. Actually, I will only draw the function area. So here, this is the function of, it is the area of rectangle PQST as function of B, as function of the width B. So here, in the y-axis, we have the area of rectangle PQST, and in the b-axis, in the x-axis, we have the width B. Okay, yeah, this axis is the axis for the width, and the y-axis is the axis for the area of rectangle PQST. And from the graph, we can easily see that when b equals to 4, when b equals to 4 units in its length, then the area is a little bit more than 40 square units, and it is definitely a maximum extreme point. Okay, so we shall find out that when b equals to 4, then the area of rectangle PQST is in its maximum value. And here you can see from the graph that it is a little bit more than 40 square units. Now we have to put the value of b is equal to 4 in this function area. A times b is the area of rectangle PQST, and it is equal to 21b minus 21 over 8 times b squared. We just have to substitute b by 4 in order to find out what is the maximum area of rectangle PQST when b equals to 4 units in its length. So we do it now. So the function area of rectangle PQST, a times b is the area of rectangle PQST, and the area equals to 21 times b minus 21 over 8 times b squared. Now we just have to substitute b by 4, because 4 is the maximum extreme point, and in this way we find out what is the area of rectangle PQST when B equals to 4. That will be, as you can see from the graph, it will be the maximum extreme point. So this point is the maximum extreme point. Okay. So the area A times B equals to 21B. So it is 21 and B is 4, so we substitute B by 4. So it is 21 times 4 minus 21 over 8 times B squared. B is 4, therefore B squared is 4 squared, that is 16. So the maximum area of rectangle PQST equals to 21 times 4, that is 84. And here we have this expression. In this expression we have 16 over 8 is 2. So in total this expression equals to 2 times minus 21, that is minus 42. So the maximum area of rectangle PQST equals to 84 minus 42. 84 minus 42 is 42. So if we found out that the maximum area of rectangle PQST is equals to 42 square units. Okay, and now we find out what is the length of rectangle PQST when its maximum area is equals to 42 square units. We know that the width B is 4, and in order to find out what is the length of rectangle PQST when the area in its maximum value that is 42 square units, we have here the length A according to equation 1. The length A equals to 21 minus 21 over 8 times B. We just have to substitute B by 4, and we get that A equals to 21 minus 21 over 8 times B, and B is 4. So the length is 21 minus, here we divide both the numerator and the denominator by 4. After we divide it by 4, in the numerator we left only with minus 21, and 8 over 4 is 2. So the length of rectangle PQST when B equals to 4 and the area in its maximum value that is 42 square units, the length equals to 21 minus 21 over 2 is minus 10.5, and 21 minus 10.5 is 10.5. So actually found out that when the width of rectangle PQST, when the width B equals to 4, and when the length, and then actually the length A equals to 10.5, then the area, it is of course A times B. A is 10.5 times B, that is 4. 10.5 times 4 is 42 square units. And therefore we found out that the maximum area of rectangle PQST is equals to 42 square units, and when the maximum area of rectangle PQST is 42 square units, then the width is 4 units and the length is 10.5 units. In total, of course, you can see that the length times the width is 10.5 times 4, that is 42 square units. Okay, so in the next step, I'll summarize the lecture. In this lecture, we found out the maximum area of rectangle PQST that is located inside this triangle ABC. So in the drawing we have triangle ABC, and inside this triangle ABC we have this rectangle PQST, and our mission is to find out the maximum area of this rectangle PQST. In addition, we know that the length of side AB of triangle ABC is 10 units, the length of side AC is 17 units, and the length of this side BC of triangle ABC equals to 21 units. Repeat again, our mission is to find out the maximum area of this rectangle PQST. So in the first step, we did a construction, that is to say from point A, we draw perpendicular on PQ. Again, from point A, we draw perpendicular on PQ. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and PQ, this point as M. In the next step, we extended the perpendicular AM by straight line until it touches side BC in this point, and we find the touching point of the extended perpendicular AM inside BC, this point as N. And actually, by doing this construction, we created here those two angles are defined as corresponding angles, and they are located between the two parallel lines PQ and BC, and therefore they are equal to each other according to the rule. They are equal to each other according to the rule that corresponding angles between parallel lines are equal to each other. So those two angles are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees because they are equal to each other. Likewise, those two angles are also defined as corresponding angles, and they are located between the same parallel lines PQ and BC, and therefore they are equal to each other. Okay? But this angle equals to 90 degrees according to our construction. Therefore, this angle must be also equal to 90 degrees. In the next step, we defined the length of this line segment BN as X. So what is the length of NC? From the drawing it is very easy to see that NC equals to BC minus BN. Okay, NC equals to BC minus BN. So NC equals to BC, that is 21, minus BN, that is X according to our definition. So in total, actually found out that NC, this segment NC equals to 21 minus X units in its length. In the next step, I copied this right triangle A and B in a new page, and we implemented the Pythagoras theorem on this right triangle A and B. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this triangle is AB, therefore the square of the hypotenuse is AB square, and it must be equal to AN square plus BN square. AB is 10, therefore B square is 10 squared, that is 100, and it is equal to AN square. AN is the missing side, so we leave it as it is, plus BN square. BN is X according to our definition, therefore BN square is X square. So according to equation 1, 100 equals to AN square plus X square. Here we subtracted X square from this equation, equation 1, and finally found out that according to this equation, equation 1, AN square equals to 100 minus X square. In the next step, I copied this right triangle A and C in a new page. We implemented the Pythagoras theorem in this right triangle A and C. This is the right triangle A and C that I wrote from the original drawing. The hypotenuse AC equals to 17 units in its length, according to what is given us the question. We just write down found out that side NC equals to 21 minus X. So in this right triangle ANC, according to the Pythagoras theorem, AC square equals to AN square plus NC square. Again, AC square equals to AN square plus NC square. AC is 17, therefore AC square is 17 squared, that is 289. And it is equal to AN square. AN is the missing side, so we leave it as it is. plus NC squared. NC is 21 minus x, therefore NC squared is 21 minus x squared. So according to equation 2, if we found out that 289 equals to an squared plus 21 minus x squared. Here we subtracted 21 minus x squared from this equation, equation 2, and finally found out that according to this equation, equation 2, 289 minus 21 minus x squared equals to an squared. This is according to equation 2, while according to equation 1, we've already found out that 100 minus x squared equals to an squared. Here is 100 minus x squared equals to an squared. So we have two different equations for an squared. And therefore, we created equation 3, which states that an squared according to equation 1 must be equal to an squared according to equation 2. An squared according to equation 1 is 100 minus x squared, and it must be equal to an squared according to equation 2. An squared according to equation 2 is 289 minus 21 minus x squared. We open the brackets of this expression, 21 minus x squared, and found out that according to equation 3, 100 minus x squared equals to 289, and here we have minus, and 21 minus x squared equals to 21 squared, that is 441, plus x squared, minus 2 times 21 times x is minus 42x. So 100 minus x squared equals to 289. Here we open the brackets of this expression. After we open the brackets, this expression will be equal to minus 441 minus x squared, and we have minus times minus is plus. Minus 42x equals to plus 42x. So according to equation 2, if we found out that 100 minus x squared equals to 289 minus 441 minus x squared plus 42x. Here we did 441 for this equation. Equation 3, we found out actually that 100 plus 441 equals to 541 minus x squared. And the other side of the equation 3, we have 289 minus x squared plus 42x. So here we have minus x squared on both sides of this equation 3. Therefore x squared will get cancelled. And after cancelled x squared, minus x squared, in this side of the equation we left only 541. On the other side of the equation we have left with 289 plus 42x. Here we subtract 289 from this equation, equation 3, and find out that according to this equation 3, 541 minus 289 is 252. So 252 equals to 42x. Here we divided this equation 3 by 42, and finally found out that x equals to 252 over 42 is 6. So x equals to 6 units in itself. That is to say, the length of this answer in Bn is equal to x is equals to 6 units, and the length of this answer in NC, that is 21 minus x, it is 21 minus x, that is 6, so it is 21 minus 5, that is 15. In the next step, we return to our first equation, that is to say, a squared equals to 100 minus x squared. We know that x equals to 6, therefore x squared is 36. And therefore a squared equals to 100, and x squared is 36. So it is 100 minus 36, that is 64. So a squared equals to 64. We took out of this equation 1, and finally found out that a equals to the square root of 64, that is 8. So here, this line segment AN is equal to 10 units in its length. In the next step, we defined the width of this rectangle PQST as B, and the length PQSA. It is given us the question that PQST is rectangle, and we know that all the angles inside the rectangle are right angles. Therefore, those two angles, they are both right angles. And in the next step, we focus on this small quadrilateral MQSN. Inside this small quadrilateral MQSN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total it must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside the small quadrilateral MQSN, we have 4 right angles, and according to rule 6, any quadrilateral that has 4 right angles must be its rectangle not a square. Therefore, we relate to this quadrilateral MQSN as a rectangle because it has 4 right angles. But according to the rule, the opposite sides of a rectangle are equal to each other, so a rectangle MQSN, side QS must be equal to the opposite side MN. But QS is B, therefore MN must be also equal to B. MN equals to B, AN equals to 8. So what is the length of AM? AM equals to AN minus MN. Again, AM equals to AN minus MN. So AN equals to AN, that is 8, minus MN, that is B. So in total, AM equals to 8 minus B. So here, we know that those two angles, they are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other according to the rule that the corresponding angles between parallel lines are equal to each other. So if this angle is alpha, then this angle must be also equal to alpha because those two angles are equal to each other. Likewise, those two angles are also defined as corresponding angles, and they are located between the same parallel lines PQ and BC, and therefore they are equal to each other. So if this angle is beta, then this angle must be also equal to beta because they are equal to each other. In the next step, we prove that the big triangle ABC is similar to the small triangle AQP. So, why the big triangle ABC is similar to the small triangle AQP? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to beta, therefore they are equal to each other. And finally, this is angle A, that is a common angle that belongs to both triangles. Therefore, angle A equals to itself as a common angle that belongs to both triangles. So we actually found out that all the triangles in the big triangle ABC are correspondingly equal to all the triangles in this small triangle APQ, and therefore those those two triangles are similar to each other according to angle similarity rule. And again, actually found out that the big triangle ABC is similar. This is the sign of similar to the small triangle APQ. According to angle similarity rule. And whenever you have two similar triangles, then the ratio between their heights must be equal to the ratio between their sides, or the ratio between their corresponding heights must be equal to the ratio between their corresponding sides. So, in the two similar triangles ABC and APQ, it means that the height AM in the small triangle over the height AN in the big triangle must be equal to side PQ in the small triangle over side BC in the big triangle. Repeat again. Means that AM over AN, that is the ratio between the corresponding heights of the two similar triangles, must be equal to PQ over BC, that is the ratio between their sides. So here AM is 8 minus B over AN is 8. Again, AM is 8 minus B and AN is 8, and it must be equal to PQ. PQ is A according to our definition. Here PQ is A over BC. BC is 21 according to what is given as the equation. So according to equation 1, we actually found out that 8 minus B over 8 equals to A over 21. Here we cross multiply this equation with equation 1, and finally found out that 8A equals to 21 times 8 minus B. Okay. Here we divided this equation 1 by 8, and finally found out that a equals to 21 over 8 times 8 minus b. Okay, so here, open the brackets on this side of this equation 1. We found out that according to this equation 1, a equals to 21 over 8 times 8, that is 21. And here we have 21 over 8 times minus b is minus 21 8 times b. So according to equation 1, we should find out that a equals to 21 minus 21 over 8 times b. A is the length of this rectangle PQST. In the next step, we multiply this equation 1 by b. And finally found out that according to this equation 1, a times b equals to 21b minus 21 over 8 times b squared. But what is a times b? A is the length and b is the width. And the length times the width is the area of this rectangle PQST. So a times b is the area of rectangle PQST. So here we created the function of the area of this rectangle PQST, or the area of this rectangle PQST is function of b. And again, equation 1 means that we have the area of rectangle PQSB, that is a times b, as function of b. B is the width. So the area of rectangle PQST, a times b equals to 21b minus 21 over 8 times b squared. Our mission is to find out the maximum area of this rectangle PQST. Or, in other words, our mission is to find out the maximum value that this function area of rectangle PQST can get, or for which b is the independent variable, the value of a times b will be maximum, or for which b the area of rectangle PQST will be in its maximum value. In order to find out what is the maximum value of this function area, we have to differentiate this function area, and then we have to equate the derivative to 0, and then we'll solve the equation that we created, and by solving the equation we get the extreme points of this function area, and then we'll draw the graph of the function area, and from the graph itself we can easily see whether if the extreme point that we found is minimum extreme point or maximum extreme point. So in the first step we actually differentiated this function area. D is the version from derivative, so we took the derivative of the function area, that is 21b minus 21 over 8 times b squared, and we took the function area according to the independent variable b, means the width of this function area. So, and we equated this derivative to 0 in order to find out the extreme points of this function area. So what is the derivative of 21b? Actually we know that the derivative of b is 1, and therefore the derivative of in total this expression will be equal to, after we took the derivative of 21b, it will be equal to 21 times 1, that is 21. So in total the derivative of 21b is 21, and then we took the derivative of 121 over 8 times b squared. The derivative of b squared is 2b, so in total the derivative of this expression will be 21 over 8 times 2b, and it is equal to 0. Repeat again. The derivative of 21b is 21, and the derivative of minus 21 over 8 times b squared is minus 21 over 8 times 2b, and it is equals to 0. So here we took 21 as a common factor out of those two expressions. So actually, what is left from 21 of 30, we took from it 21 as a common factor, what is left is 1. What is left from this expression, minus 21 over 8 times 2b after we took from it 21 as a common factor, what is left? It's actually minus 2b over 8, and is equals to 0. Here we divided this equation 2 by 21, and found out that 21 over 1 is 1, so in this side of equation 2 we left only 1 minus 2b over 8, and the other side of the equation we have 0 over 21 is 0. So according to equation 2 we actually found out that 1 minus 2b over 8 equals to 0. Here we added 2b over 8 to this equation, equation 1, and finally found out that 1 equals to 2b over 8. Here we divided both the numerator and the denominator of this expression by 2. We found out actually that 1 equals to 2b over 2 is b, and 8 over 2 is 4. So in conclusion, according to equation 2, we found out that 1 equals to b over 4. Here we multiply this equation 2 by 4, and finally found out that b equals to 4 units in its length. That is to say, the extreme point of this function area AB equals to 21b minus 21 over b squared. The extreme point is when b equals to 4. In the next step, I draw the function area of this rectangle PQST in order to verify that when b equals to 4, it is indeed maximum extreme point and not minimum extreme point of this function area. So actually, this is the graph of the function area of this rectangle PQST. In the y-axis, we have the area. In the x-axis, we have the width b. You can easily see from the graph that when b equals to 4 units in its length, then the area is in its maximum value. This is a little bit bigger than 40 square units. Therefore, we found out that b equals to 4 is maximum extreme point of this function area, because we have here this maximum extreme point. Okay, now the only thing that is left to do is to find out what is exactly the area, the maximum area of this rectangle PQST when b equals to 4. This is to say we have to put the value of 4 on this function area of this rectangle PQST. In this way, we will find out what is the maximum area of this rectangle PQST when b equals to 4 units in its length. Again, the function area, A times B is the area of rectangle PQST, and it is equal to 21 times b minus 21 over 8 times b squared. We just have to substitute b by 4. We did it and found out that a times b equals to 21b, so b is 4, so it is 21 times 4 minus 21 over 8 times b squared. B is 4, therefore b squared is 4 squared, that is 16. So found out the maximum area equals to 21 times 4 is 84. In this expression we have 16 over 8 is 2, and minus 21 times 2 is minus 42. So the maximum area of this rectangle PQST equals to 84 minus 42, that is 42. But again, the maximum area of this rectangle PQST equals to 42 square units. and we get the maximum area on this rectangle PQST when the width B equals to 4. So what is the length of the rectangle when B equals to 4? We have the equation for the length. The length is A, so A equals to 21 minus 21 over 8 times B. We just have to substitute B by 4 in order to find what is the length of this rectangle PQST when B equals to 4, and when the area of this rectangle is in its maximum value, that's actually 42 square units. So the length equals to 21 minus 21 over 8 times B, and B is 4, so substitute B by 4. So it is 21 minus 21 over 8 times 4. Here we divided both the numerator and the denominator of this expression by 4. So in the numerator we left only with 21 because 4 over 4 is 1. In the denominator we have 8 over 4 is 2. So in total, this expression, after we divide both the numerator and the numerator and the denominator by 4, is equals to minus 21 over 2. So in total, the length A is 21 minus 21 over 2. Minus 21 over 2 is minus 10.5. And the length equals to 21 minus 10.5. This is 10.5. In conclusion, also found out that when the width of this rectangle PQST that is inside triangle ABC, when the width equals to 4 and the length equals to 10.5, then the area A times B is of course 10.5 times 4, that is 42 square units. Then the area of this rectangle PQST is in its maximum value, that is 42 square units. Okay, thank you very much.